3 HomePods from Lee here that we gotta knock out. Let's go ahead and see which one we grabbed first. What are the chances? What are the chances we grabbed the bricked one first? Mike, welcome. Hope the other side of the state's treating you well. And there we have it, our blinkies. We're just grabbing ourselves a working logic board here. Unfortunately, parts for these have gotten so expensive to come by that I've just started picking apart my own HomePods. Because I can't afford more than... I can't afford what people are asking for these, and people probably aren't going to want to pay to fix them for how much I'd have to charge based on that. And frankly, I don't need all the HomePods I have, so I'm willing to dip into my own stash for a little bit. It hurts, but it's what we gotta do. Alright, into the pile. Very sad. Do you know you can use that for YouTube music? Oh yeah, I heard one of the recent software updates let you change the music app. I personally still AirPlay everything. I don't really use the voice commands for anything other than turning lights on or off. But it's a very welcome thing to finally see. So we're just going to tear this apart a little further. We're going to get that subwoofer out so we can take a peek at the insides. Make sure there isn't anything else that needs any attention that would cause any problems in the near future, or anything that we know of that will inevitably fail. I'm talking specifically about that Schottky diode that loves to fail and cause no power. We can tell if it's the good one or bad one based on the date code on it. And then we're also going to plug our test woofer here into the amplifier. That's going to let us test the amplifier's output for how clean its signal is. How clean or dirty it is, basically, eventually if it's too dirty it'll lead to death farts, and by dirty we mean too much DC voltage coming out. And we've got our multimeter over here plugged into the subwoofer. You can see that number jump a little bit when we stab it. I'll believe Apple's really opening it up when they let us restore the software. Good looking woofer there. 42K dated diode. So no worries about no power issues coming from that. And this also gives us an opportunity to make sure that this logic board works with their HomePod. Okay. Beautiful. So it looks like all this needs is the logic board. No diode, no filters. So let's get that put back together and we will take a look at the rest of them. Pretty much every time. Yeah, that's correct, Mike. On rare occasion, we've got some other random board failure, power supply failure, physical damage, but almost every time it's this board here. So that means these will be no power. Show me those volume buttons. Talk to me.
I'm having trouble connecting to the internet. For more info.
There we go. All right. Gonna put an R on here so that way we remember to reset that. Here's the next one here, presumably with no power. Yep, about 6 watts of power draw. Nothing else happening there, so appears to be that usual dead diode. Let's jump into it. How many HomePods are we averaging each day? We only have the time to do 2 or 3. Hasn't changed. Yeah, it hasn't really changed at all how many we've had coming in. It's pretty much all been the same, which is kind of wild. All these HomePods. Yeah, she's a monster. We have to reconstruct the living room every week because of some physical advancement she's made in escaping. There it is, 46K, folks. The devil. Let's see here. There we go. Sorry, I had a friend that wanted to watch us stream a little bit here. Let's get this fresh new diode on here. And to answer your question, yes, all we need to do is replace this diode. We don't need to worry about it failing again. The part that Apple used is perfectly fine for the job. It is purely just a bad batch of these diodes floating around in these HomePods causing these problems. So, just by replacing the same diode with the same part that's newer, we prevent that problem from happening again. We get that asked a lot, like, does the repair last? Of course it does. We wouldn't be doing this if it didn't. But just to be extra sure, we do replace these with a slightly beefier version of it. It's a slightly higher rated, and the manufacturing process is held to slightly higher standards than the part that Apple used. So it's not a necessary replacement that you gotta run out and do to all of your HomePods if they're working just fine. Don't worry about it. Only worry about it if your HomePod actually breaks on you. And the good thing is, when this kind of failure happens, usually, pretty much every time, it's just this diode and nothing else. So another question I get a lot from people is, can I send my HomePod into you if it's working just fine to get the diode replaced ahead of time? And I tell them, frankly, it's not going to cost you any more or less, because it's going to be the exact same amount of work if we do it before or after it fails. Same amount of parts, same amount of time, same amount of effort. So just don't worry about it until the HomePod actually gives you issues. No sense spending money on sending it into us to take it apart just to find out you don't even have one of the bad diodes in there waiting to fail in the first place. Your solder never seems to hold. Make sure you have you can see my iron's cranked pretty high up there. Make sure you got your iron turned up. I'm fairly positive I've got the solder and the flux that I use at the bottom of my website. But make sure you're using some kind of like 60-40 leaded solder, something around there. Doesn't need to be rosin core if you've got some good flux, but pretty much everything you find these days is going to be rosin core anyways. Crank up the heat on your iron. Don't be afraid of that. Okay, so we've got our test woofer over here plugged into the amplifier. We've got a multimeter in DC mode plugged into the subwoofer. So we're going to power this up and see how clean or dirty the amplifier's output is, which gives us an idea of how good or bad the filters on the amplifier are, which is the second most common problem with these HomePods. Those go bad and cause death farts, no bass, crackly bass, what have you. So, generally, whenever we work on a HomePod, regardless of what issue it's coming in for, there's 3 things we do. We check the date code of the diode. If it's within that date range that's normally bad, we replace it to prevent the power issue. We've got the filters to check for death farts, DC offset, no bass, crackly bass. We check that by testing the output with a multimeter. And then we just do a general inspection of the condition of all the parts, make sure there's nothing out of whack there. So we've got power. We've got only 1 millivolt of DC coming out of the amplifier, which is excellent. That means this is fixed up and doesn't need anything else. We can put it back together, make it look like a HomePod again. Oof. So what we're looking at on the multimeter there, when we test them, when we power them on, we had 1 millivolt of DC coming out, which is a great result. A bad result is anything more than 50 millivolts, and even that is pretty low compared to the actual tolerance of the main amplifier chip on the board here. The main amp chip can actually tolerate up to about 200 millivolts. So we cut it way earlier than that. We say that when the filters have 3/4 of their life or less left, essentially, then we go ahead and replace them. It's like changing the oil filter on your car every 1,000 miles instead of the 3,000 to 5,000 miles. Or I guess nowadays you got oils that go up to like 10,000, 15,000 miles. That's pretty insane. You won't catch me doing that though. How does solder jump from iron to the diode? So that has a lot to do with the flux and surface tension. So when we get the copper substrate on the diode hot enough, it'll melt with the solder and create a new alloy that actually physically bonds the solder to the copper on your diode, or any other copper trace or pin or pad or whatever it is you're soldering to. And it's the surface tension, when that alloy is created, it transitions from copper, alloy, and then solder. It's that alloy that's sucking the solder in, and the solder that's pulling on that alloy, that's pulling the solder off your tip. It's not probably the best explanation, but one of my favorite playlists on YouTube that helps explain how soldering works a lot is there's this PACE. It's this really old like PACE engineering playlist on the basics of soldering. And that was one of my big like aha moments when I was watching one of those videos a few years ago, was they were explaining how soldering actually, what actually happens when you're soldering. Up until that point, I thought soldering was just basically getting metal, like the leaded metal hot enough to melt and just kind of hold things together with a conductive material, but that's not the case. It's actually blending with a little bit with the actual materials and creating a new alloy. So once you understand that, then you need to understand the conditions required for that to actually happen. corrosion and oxidation won't allow that solder to transfer and create that alloy. So no matter how hot you get it, if you've got dirty copper or dirty pads, it's not going to transfer. It's not going to melt. Well, it'll melt. It'll just kind of sit there in like a puddle, and it'll just kind of flake off if you scrape at it. That's not what you want. And that's where the flux comes into play. The flux basically just acts as like a cleaner that gets rid of that dirtiness that's stopping the solder from properly interfacing with the material you're trying to solder to. And once it's clean, it can properly bond. And once it can properly bond and alloy up, it'll start sucking more solder off your tip as it fills in that alloy. So that's my kind of informal explanation of how that works. Hope it made sense for you, Mike. power. Hello.
I'm having trouble connecting to the internet.
Beautiful. That leaves us with number 3 here. I believe also no power. There we go.
I'm having trouble connecting to the internet. I'm having trouble.
Beautiful. Folks, that's all that we've got the time for here and now. Stay tuned. We've got a whole bunch more to get fixed up. So subscribe to catch that, and I'll catch you in the next one.